Many of the measurements that we make in the Echo Lab have to be adjusted to the size of our patient. They don't necessarily tell us a lot unless we know about the size of the patient. And as you all know, our patients come in many different sizes. So here, as an example, we have two patients. One is a patient that is 5'9" and weighs 185 pounds, and the other is a patient that is 6'6" and weighs 360 pounds. And if we're going to talk about a measurement, let's say for instance of cardiac output. Let's say we have a cardiac output of 4 liters per minute. 4 liters per minute may be an adequate cardiac output for the first patient, but it may not be adequate for the second patient that's much taller and much heavier. So what we need to do is we need to take our cardiac output and relate it to the size of the patient using a parameter that is called the body surface area. So we'll talk about the body surface area and how we calculate it, but before we do that, let's talk about how we're going to convert our units of feet and inches over to centimeters and our units of pounds over to kilograms, because that's what we're going to need in order to calculate out body surface area. So let's look at the example of the first guy. He's 5'9" and weighs 185 pounds. Now if we want to convert these numbers over to the metric system, let's first look at height. And to convert the height, what you're going to do is you're going to take your height in inches, and you are going to multiply it times 2.54 centimeters per inch. So when we do that, our units of inches will cancel each other out, and we'll be left with our height in centimeters. So in this case, 5'9" is 69 inches. So 69 inches times 2.54 centimeters per inch gives us, I'm going to round it off to a whole number, 175 centimeters, because our inches will cancel out. So this person that's 5'9" is 175 centimeters. When we're converting weight conversion is another simple formula, because our weight is basically, we take our weight in pounds and we divided by 2.2 kilograms per pound. So once again, our units of pounds will cancel each other out and we'll just be left with kilograms. So in this case, our 185 pound patient, 185 pounds divided by 2.2 kilograms per pound. Again, rounding off to a whole number, that will give us 84 kilograms, because our pounds will cancel each other out. So 185 pounds is 84 kilograms. Now looking quickly at this other example, somebody that's 6'6", that's 78 inches, and 78 times 2.54 gives us 198 centimeters. And they weigh 360 pounds, so 360 divided by 2.2 leaves us with 164 kilograms. So there's our conversions, there's our units, and now we can start talking about how we're going to take these numbers and calculate out the body surface area. Just to go back and jot these things down one more time, 5'9" is 175 centimeters, 185 pounds is 84 kilograms, and in our case of our second person, 6'6" is 198 centimeters, and 360 pounds is 164 kilograms. Alright, so we want to talk about body surface area and how we calculate out body surface area. The way that I use it, there's several formulas that are available for body surface area. If you search the net, you'll find them. I'm going to use a formula that I think is most commonly used. It's called the Du Bois formula. And when we're calculating out body surface area with the Du Bois and Du Bois formula, body surface area we are going to say is BSA, body surface area. And you take your height in centimeters, and you take it to the power of 0.725. Then you take your weight in kilograms to the power of 0.425. And we have to be able to take centimeters, kilograms, and when we're all said and done, our unit is going to be meters squared. So in order to get those conversions, there's a conversion coefficient of 0.007184. So that is our body surface area formula using the Du Bois formula. So let's start plugging in some numbers. Here we have this first patient that we said was 175 centimeters. So we take 175 centimeters to the power of 0.725. And we have 84 kilograms. So 84 kilograms to the power of 0.425 times our conversion coefficient of 0.007184. So break out your calculators and do that math, and you'll get a body surface area that is equal to 2.02 meters squared. So that's the body surface for the first person. Now let's quickly go through doing that again for the second person. So the body surface area for our second person is equal to the height in centimeters, which is 198 centimeters, to the 0.725 power, times the weight in kilograms, which is 164 kilograms, to the 0.425 power, times our conversion coefficient of 0.007184. So again, plug those numbers into your calculator and you will end up with a body surface area that is equal to 2.49 meters squared. Now, if you recall when we first introduced this topic, we said both of these people had a cardiac output of 4 liters per minute. Let's see how that works with the cardiac index now. Let's take this cardiac output and index it with the body surface area. So in the first case, we have 4 liters per minute, and we're going to divide that by the body surface area, which we said was 2.02 meters squared. And when you plug that into your calculator, you should get 1.98 liters per minute per meter squared. That's our unit for cardiac index. And in the case of the second patient, we have the same cardiac output of 4 liters per minute, and we're going to divide that by the body surface area of 2.49 meters squared, and that is going to give us a cardiac index of 1.38 liters per minute per meter squared, which demonstrates that this cardiac output of 4 liters per minute is much different when we relate it to body surface area. And so it may be adequate for a person that's 5'9" and weighs 185 pounds, but it is most likely inadequate for somebody that is 6'6" and weighs 360 pounds. So that's body surface area, and that's unit conversions. If you have a topic that you'd like me to try to cover, go ahead and drop me an email. You can email me at kd.horton@centurylink.net, and I'll try to put something together for you. Thanks a lot.